Hello everyone, this is Vasant, a 9-pointer at IIT Bombay from the Department of Civil Engineering. In this video, we are going to discuss about torsional loading. In previous video, we said why we need to study this topic, and we also said that because of the torsion, shear stress will develop. So if there is shear stress, इसका मतलब है there will be shear strain. Because of the shear strain only shear stress will develop. So let us find the formulas for shear strain in case of torsion. So if you take a circular member with radius r, radius capital R, then if you take inner circular element with radius r, then if you take a line BA, then it will deform like this, right? Then if you consider AA dash will be is equals to gamma into L, that will be is equals to R into phi, right? So gamma into L is equals to R into phi, that will be is equals to gamma is equals to R into phi divided by L. What is phi? Phi is angle of twist. But because of the torsion, how much angle it twisted? So that is angle of twist. So gamma is equals to R phi by L. Gamma is shear strain. R is radius from the center. Phi is angle of twist. L is length. This is angle of twist. This is radius. Right? So what will be the gamma max? Gamma max will be is equals to R max, right? R max is R, so R phi divided by L for a circular bar. Now let us know about circular tubes. For circular tubes, this will be hollow. So there will be gamma minimum value. In previous case, gamma minimum will be 0. Here gamma minimum will be is equals to R minimum phi divided by L. R minimum is R1 phi by L. Gamma max will be is equals to R max phi by L. That will be is equals to R2 phi by L. Right? This is about shear strains in circular tubes. Now let us go to shear stresses. We already know that shear stress tau is equal to G into gamma. So in this case, tau max will be is equals to G gamma max, that will be is equals to G into R phi by L. In this case, tau minimum is equals to G into gamma minimum, that will be is equals to G into R1 phi by L. Tau max will be is equals to G into gamma max, right? So that will be is equals to G into R2 into phi divided by L. So if you consider tau at any position, then it will be G into R into phi by L. So this means G phi L are constants. So tau is directly proportional to R, right? So it is linearly varying with R. So this is the reason why we draw it linearly. Okay, understood? Now let us derive the torsional formula. So for torsion formula, if you consider a small element, then the force on that element due to shear stress will be tau dA, and due to that the moment at the center will be is equals to R, right? So integration 0 to capital R will give me the total moment, that should be is equals to torsional moment, twisting moment, right? So that the integral 0 to R at position R, what is value of shear stress? That will be G R phi by L dA into R, right? So T will be is equals to 0 to R G phi by L R square dA. So G phi by L are constant. So G phi by L integral R square dA 0 to R. So T will be is equals to G phi by L integral 0 to R square dA, right? So integral 0 to R square dA is known as polar moment of inertia. It is denoted by J. Okay. So T is equals to G phi J divided by L. So if we write phi, angle of twist will be is equals to T L divided by G J. Okay. This is the torsional formula for a torsion member. See, if you see over here, if it is fixed at one end and the circular member is of length L, then this angle of twist is at x is equals to L. So for random x, then phi should be is equals to Tx divided by G J Jx, right? So for that process, if you need to know what is the angle of twist at this position, this is at x, then this will be the formula, right? Phi at x. So as this is a uniform circular member, so Jx will be is equals to J and Gt are same. G comma T, Tx we need to write here. X. Okay. So this is about torsional formula. Let us summarize the whole thing. First, we got shear strain gamma, that is equals to G phi by L. G phi by L. Sorry, shear strain gamma is given by R phi by L, right? So and from that we get tau is equals to G shear strain, that will be is equals to G R phi by L, right? And we derived the torsional formula theta is equals to TL divided by GJ. Okay, these are three relationships. From this we will get gamma max. Gamma max will be is equals to R phi by L. From this we also get that gamma by gamma max will be is equals to small r by capital R. Gamma will be is equals to gamma max divided by R into small r. Okay, and from this we get that tau is linear with R. Tau max is equals to G gamma max, so that is equals to G capital R phi by N. From this we get theta at x will be is equals to Tx, will be x divided by Gjx. Okay. So with this we end today's lecture. In next few lectures we solve some problems on torsional loading. Thank you.